Welcome, Algebra 3 students. We're in Lesson 44. We're going to talk about abstract rate problems with this lesson. And I am not going to go kid you. I'm going to go ahead and tell you that these are hard and they're confusing and there's a lot of moving parts. And you really have to focus on the terminology used in the problem to figure out the right way to do it. So let's just jump in. We'll do 44.1. We have 4 practice problems. And they may take a little time, but we're going to do each one and analyze each one independently. So instead of me having to write all of this out, I'm just going to read it to you and write down the pertinent information. So 44.1 says that Peter purchased P pencils, so P pencils, for D dollars. P pencils for D dollars. If the pencils had cost X more dollars, so that's part of the problem, there's going to be a change. So the change is going to be that we have X more dollars for the pencils. How many pencils could Peter have purchased for $20? So how many P pencils for $20? All right, so this is all the information that we have. We know that he got P pencils for D dollars. That's our rate. So that's the first thing we're going to do is we're going to create an original rate. And then we're going to take into account the new or the changed rate. And then we're going to use that information to solve. And we're going to pay attention to the terminology as we do this. So what I am seeing is that all of the pencils that he bought, the total amount of pencils that he bought was for this price. All right. So it's a group of pencils for a total. The total is not per pencil. It is for all of the pencils. So the change, X more dollars, means it's saying that we're adding X dollars to the total price. That's what it's saying. So let's do our original rate first. Our original rate is going to be P pencils per D dollars, or we could say D dollars per P pencils. That would give us our rate. The changed rate, however, is going to be adding X dollars. So I think probably the easiest way to do that is P over, not X, hello, D plus X, where P represents the pencils and D plus X represents the dollars. So this is our rate. So at this rate, how much can we get for $20? So we're going to take our rate and we're going to solve it for that $20. So P over D plus X, P pencils over D dollars plus X times the $20. Now we are going to treat this like a whole number, put that over 1. We're going to cancel our dollars. So we know now that we can get 20 P over D plus X pencils. All right, so we solved it as a group price. This is a group price, okay? All right, so let's do 44.2. Let me clear the page. And I will read 44.2 to you. This one's a little tricky. The coach purchased B basketballs for X dollars. So X dollars. There is our rate. That is a potential rate. all of the basketballs for a total cost, right? If each basketball had cost $3 less, how many basketballs could the coach have purchased for $20? So we could use this rate, or we could use X over B dollars over basketballs. So here's what I'm seeing in the book. It says, if each is a key word. This is all of the basketballs for this total price. That is how we solve the rate. We take the total number of basketballs. So for instance, if we had $20, right? And that allowed us to buy 2 basketballs, we come up with a rate of $10 per basketball. And then we would subtract 3 from this fraction, right? So that would be $7 per basketball. We cannot just say X minus 3 on the top here, because we don't know what the divisor here, we don't know what the denominator for basketballs is. We don't know how many that is. So we have to take this entire rate and subtract 3 from it, just like we did here, right? Because we don't know. We don't know what that number is. So that is going to make this is our original rate. Because we're talking about dollars, because it says if each basketball was $3 less, so we are going to put dollars in the numerator because we're talking about the cost of the basketball. So dollars per basketball, $3 less per basketball. That's each per basketball. So this is the one we're going to use, not this version, because it's basketball per dollars. This is dollars for each basketball. So this is one we want to use. All right, so we're going to set this up now. So because this is our rate, we have to say X over B. This is the whole rate, the total price divided by the total number of basketballs. That's going to give us our per basketball cost. So we're going to take our per basketball cost minus $3. And then that is our dollars per basketball. So you really have to talk some of these through to figure out which way you need to use the rate. What rate do you need? So this is our new rate. This was our original rate. This is our changed rate. And then the question says, how many basketballs could he purchase at this rate? How many can he purchase for $200? So for $200, how many? What's the quantity? So we know that for and of could mean multiplication, right? So I'm going to multiply this by the number, because this is the rate, dollars per basketball. If you multiply, this is going to give us the number of dollars per basketball times the number of basketballs. That's going to equal $200. Right? But we cannot do this calculation with this complex fraction expression thing over here. We need to normalize it and turn it into one fraction or one term so that we can actually perform what we need to perform. So I'm going to say, I'm going to turn this into a common denominator by multiplying this times b over b. So that's going to give me x minus 3b over b. And that is dollars per basketball. I'm just going to shorten that. Times the number of basketballs is going to give me $200. All right. This is a factor. This whole thing is a factor times this factor. We know when we have a factor times a variable that we can divide by the one we know to solve for the one we don't know. So I'm going to divide both sides by this, and that is going to look like this. 200, I'm going to change this to say dollars, just so it'll help me with my cancellation, so that it all looks alike. I mean, that's really all it is. So this is going to be x minus 3b over b, and then that is dollars per basketball. So now what I'm going to do is I am going to imagine there's a little line that connects these. I am going to keep it, change it, flip it. So that would become, let me do it over here, 200D, I'm just going to put D for dollars just to make that short and easy to remember what I'm doing, over 1 times B over x minus 3b, and this, my little dotted line, I have basketballs, and I have D for dollars. Okay, so now these are all factors to one another. So D's cancel, and that's all I can cancel. So N is equal to, the number of basketballs can be written at this rate, 200 times B over x minus 3b in basketballs. So the tricky part here was the fact that it said if each basketball costs $3 less. In the first problem, it talked about the whole group was increased. The price for the total purchase of all the pencils had X dollars added to it. In this problem, each basketball independently was reduced by $3, and we didn't have access to that. We couldn't say X minus 3 because X represented the total purchase price, and B represented the total number of basketballs. So in order to get to that individual price, we had to do this fraction and get our rate, and then take 3 from that value. So that was the tricky part in this whole thing, understanding each versus the group. So pay attention to the language that is used in the question. All right, that's just one of those tricky things about word problems. They'll throw little things in there like that, and it can change your entire calculation. So let's move on to 44.3. Let me clear the page here. Okay, so 44.3 is talking about an assembly line and workers and how many things that they can produce. Excuse me. So it says on an assembly line, this is 44.3. On an assembly line, okay, wherever is great, we have M workers. So M is equal to workers. They worked H hours to produce C articles. Okay, from that, we can derive our rate. All right, our rate in this problem is in articles per worker per hour. So, however fast they worked, that's our rate. And that is going to be the number of articles that they make, the C articles, that the number of workers we have can make in a certain amount of hours. So MH is going to be worker hours. Now I know in the book this is a hyphen, worker hours is a hyphen, but it's really two things multiplied times each other. That's like if you were to say, I have 4 workers who are working 6 hours each today. I actually have 24 worker hours that I have to pay, right? So you would say 24 times what let's say the wage you're paying is $10, you'd have to pay $2.40 for these 4 workers for the 6 hours that they each worked. That's why it's multiplied. All right, it's multiplied. It's not a hyphen in here. It's not 4 minus 6. And in the book, it has workers hyphen hours. I know it's just hyphenating a word, but it's actually multiplication. The more people you add to a job, think about it realistically, the more, there's the saying, many hands make light work. That's because the more workers you apply to a job, right, the more you are increasing the amount of work they can do. So that's what this rate also implies. I don't know why I have a B here. That should be an H. Hello. All right. So the more workers you have in a given time, that is directly or inversely proportional, whatever, to the number of articles that can be produced. All right. That is the rate. The number of articles produced is directly affected by the workers and hours. All right, I think I've beat that horse to death. So let's move on to the next sentence. That was just the first sentence. If D workers quit, oh no. So now our worker has changed. Now our workers in the new rate, we have M minus D is our workers for this new scenario that we're given, this change. How many hours would the remaining workers have to work to produce the same number of articles? So we would have to take our rate, this rate that we've already set, times the number of workers we have now to account for the decrease, times the amount of time that it would take them to do it to get the original C articles, right? The amount of articles that we had to start with. So we would just take this information and drop it in. C articles, or items, however you want to say that, over M times H, which is our worker hours, and you'll see why I put this in parentheses in just a little bit, times the new quantity of workers, which is going to be M minus D, and that is in workers. I'm just going to shorten it. Times time is equal to the original amount of C articles. We need to see how many we need, or how long is the variable that we need to produce the C amount of things. So again, just like in our previous problem, we had an unknown, which was the number of basketballs that we could buy for the $200 with a reduced price. Here we have the amount of time. We don't know what the amount of time is for them to create the same number of articles. But we have two factors. Instead of before we just had the one rate, now we have the rate times their decreased workers. So we're going to adjust that. I don't know why I keep writing a B for the H. That's just crazy. I'm losing my mind. And we can't apply that here. We can't just say M minus D times H, because this is a unit. This is a factor here, right? It would mess this whole expression up. It's a different value. So we have to put the new number of workers in here as a separate thing. That's why this is the equation that it is. But what we can do is we can take these two factors and we can simplify by going ahead and multiplying them and knocking it out. So what I do see is that we can cancel workers right there. And that's going to give us M times, or C times M minus D. So this is going to be C times M minus D, and we've eliminated workers because it was a factor, because this is all one problem, right? C times articles times M minus D times workers, M times H times workers times hours. So we were able to take away the workers that way. We still have C times M minus D articles. I'm just going to put art for short. And then we still have M times H with the unit of measure hour. And this is why I wanted to put workers in the parentheses, worker and hour in parentheses, so you could see that they're actually factors. And that will help you cancel a whole lot easier when you realize that all of these things are factors, right? These units of measure, they're factors. You can cancel them. Now that is times time. And it still has to equal out to the number of articles. But now that we have it down to one factor times a variable that gives us a solution, we can divide both sides by this factor that we know. So that's what I'm about to do now. I'm going to say time is going to be equal to C articles over C times M minus D times the articles over M times H times the hour. Now we know that this is the big division line, so we're going to keep it, change it, flip it. Let me do that really quick over here. C times the articles over 1, that's our top, times, and I'm going to flip it. This is going to be M times H times the hour over C times M minus D times the article. Okay, so here's what I see. I can cancel the C and I can cancel the article. So what I am left with is that my equation for time, T, is going to equal M times H, so the number of workers times the number of hours, divided by the number of workers minus the ones who left in hours, because that's the only unit of measure I have left. And that is your answer. That is correct. So you just have to walk yourself through these, and it's okay to talk out loud. I promise, I do it all the time. People will just think you're nuts. That's all. It's not a big deal. So let's erase this and go on to the last problem for this lesson. And it's kind of difficult, but we're going to wrap our heads around it. We're going to do it. 44.4. Charles had P pounds of food. All right, so P is equal to pounds, and this is our food. That equals our food, right? Actually, I don't even need the equal sign. P pounds is equal to our food. And this would feed M workers. So M is our workers. It's what equals workers for D days. Okay, this is our original rate. So we're going to create an original rate with what we're given in the first sentence, just like we've been doing. So it looks to me like the rate is food per worker per day. So worker per day is a worker day when we multiply the two together. Because we're going to multiply those because the number of workers, again, with the hours, the number of workers you have affects the number of days of food you have to have. So that means if I have 42 workers and I want to supply them with 3 days worth of food, then I need to have 126 days worth of food in order to, prepare them. So that can easily be 126 is going to be the same thing as 42 divided by 3. That's going to be the same quantity, 1 over 1, right? So that's what this equals. So this is how we're going to build our rate. We're going to do the same thing. The food, the rate is going to be equal to the food over the number of workers times the number of days that we have to feed them. And that's going to create a worker day. And the food is going to be represented by P pounds. And I think what I'm going to do is I'm just going to use the abbreviation for pounds, just to save myself some writing. So there's that. All right, so there is our original rate. P pounds of food for this many workers in this many days. Now there's a change. There's always a stinking change. So here's our change. 30 more workers show up. So now we have the new amount of workers is M plus 30. That's our new workers, or our worker change. All right, our workers change, and now we have M plus 30. So what would be our equation that we needed to use here? So the rate of food that we have to have times the number of workers, okay, times the amount of time that they're there is going to equal how much food we need. Yeah, because that's what we figured out up here. The number of workers times the number of days is going to give us the amount of food we have, but the rate at which they consume it is important too. All right, so we got to put that rate in there so that this is all a true equation. Now we have to adjust it for our new amount of stinking workers. So let's do that. So now our new rate, let's put our old rate in. Our old rate is P pounds over workers times days for worker days times the new workers. So M plus 30 times workers times time, let me scooch this over just a little bit, is equal to the amount of food that we need. So P pounds. All right, so just like we did in the previous, I am going to condense these two into one expression as much as possible to make it easier to bring this over and divide it here. So if I put this over 1, it becomes 2 fractions. So I end up with, I can cancel the workers from here and here because they're factors. And I end up with P times M plus 30 pounds over MD days. All right, and then that is times T, and that is equal to P pounds. So now I can divide by the factor that I have. So T is equal to P pounds over P times M plus 30 pounds over MD days. All right, so now I'm going to do keep it, change it, flip it over here to the side. P pounds over 1 times, and then the bottom goes to the top, MD days over P times M plus 30 in pounds. So here's what I see. Pounds cancels, P cancels. So the amount of time is going to be determined by M times D over M plus 30, and that's in days. And that is my answer. Okay. So the number of workers times the number of days we want to feed them, divided by the new quantity of workers, that gives us the number of days that we have food, which makes sense when you talk it through like that. All right, so it's all about understanding what the question is asking. I mean, from the very beginning, all of our word problems have been, what is the question asking? What do I need to focus on? So really think about the word problems. Look for those tricky words, like where it goes from the total to the each, and how to put together the equation. You need to figure out, the rate, the worker, times the time is equal to the job. And the job was eating the food, right? It's all about the job. Traveling the distance is the job. This could have been distance, right? So wherever distance can be replaced with the job, that is the job. Sometimes you have to think creatively about what the job is. Sometimes it's babies in a nursery drinking milk. Their job is drinking milk. Here, it was workers eating food. So food was the job, and you had to learn how to substitute that in. So we're going to have some practice problems after this. I know they're complicated, and I know they're confusing. Do not hesitate if you're stuck to ask for help on these and clarification on what the question is asking, because they are hard. These are hard. These are big old boogers. So I will let you go do these practice problems, and I'll see you in lesson 45.